Yeah. So far we discussed about green building construction material, eco-friendly material, lime. Next, lime Pozzolana cement. Next material is lime Pozzolana. So here you can see Pozzolana cement, Pozzolans. Supplementary cementitious material is also. So here here you can see different various colors available. Pozzolana cement. Okay. So the Pozzolana, the name came from the town Pozzoli, Italy. It is in Italy, and here ancient Romans produced a hydraulic binder. Ancient Romans in 100 BC produced a hydraulic binder by mixing hydrated lime with soil. Means in the previous present before we told that lime is available in the form of hydrated lime. So hydrated limes mixed with some soil will become pozzolana. Okay, right. So it is predominantly volcanic ash. Soil is nothing but some volcanic ash. Okay, fine. Porous and mortar mixing lime with the finely divided burned clay is extensively used by Ottomans. Okay, so fine. Nowadays, the word pozzolana covers a broad range of natural and artificial materials. So pozzolana is using in various applications. That's what the sentence means. Okay. Right. So pozzolana is simply hydrated lime plus soil. The soil is nothing but the volcanic ash. Okay. So about pozzolana, it is a material when used in conjunction with Portland cement. So pozzolana is used in conjunction with Portland cement and contributes to the properties of the hardened concrete through hydraulic or pozzolanic activity or both. So in pozzolana almost act like a Portland cement. Okay, and it is almost act like a normal cement only, so that it gives that hydraulic nature and pozzolanic activity or both. Okay, so natural means volcanic ash, volcanic tuff, and humicide. So natural pozzolana consists of its volcanic ash, volcanic stuff, and humicide. And artificial pozzolana consists of fly ash, okay, silica fume, and granulated blast furnace slag. So this pozzolana is two types: natural pozzolana and artificial pozzolana. Okay, so natural consists of volcanic ash, volcanic tuff, and humicide. Those three materials. And artificial fly ash, silica fume, and granulated blast furnace slag. So these are the materials you have to remember. Okay, these two types, natural and artificial. So it is a pozzolana is a siliceous or aluminous material, which in itself possesses little or no cementitious value, but will definitely divide form and in the presence of moisture. Chemically react with calcium hydroxide to form compounds possessing hydraulic cementitious properties. So what you have to understand from this slide is pozzolana. It possesses calcium hydroxide. Okay, and it chemically react with calcium hydroxide. So simply pozzolana is also a like your normal cement whole line. Okay, it also can react with the calcium hydroxide. Okay, there is nothing to confuse. It also act like normal cement only. It is a binder. Okay, and these pozzones classified into two: silica and alumina in higher amounts, and then iron oxide, calcium oxide, magnesium oxide, and alkalis in lesser amounts. So pozzolana, one type consists of silica and alumina higher amounts, and iron oxide, calcium oxide, magnesium oxide, alkalis in lesser amounts. Okay, these pozzolanic reactions means this all this combination will react and give hardness, no? Give binding and give adhesiveness also. So calcium hydroxide plus silica plus water, these three together give calcium silicate hydrate. Okay. So calcium silicate hydrate provides the hydraulic binding property of the material. Means when bricks are there, between the brick and brick, if you apply pozzolana, there should be some bonding should happen to make it strong, to make wall strong. So this calcium silicate hydrate provide a hydraulic binding property of the material. Okay. So what is pozzolanic activity? So means the performance of this pozzolana is nothing but pozzolanic activity. Let us see what is that. Capacity of pozzolana to form aluminosilicates with lime to form cementitious products. What is pozzolanic activity? Pozzolana is nothing but silica plus uh, clay plus lime, right? So the clay is nothing but volcanic ash. So pozzolanic activity, when lime is joined with the clay, it will give that cementitious product. Okay, by mixing, giving the cementitious product is nothing but pozzolanic activity. Okay, means after combining this clay and lime, we get pozzolana. That pozzolana, how active is depends on how good and how active this pozzolana bind with the brick or wall or whatever the stone with which we are constructing the structure, green building structure. Okay, so what factors affects the pozzolanic activity? Amount of silica, amount of aluminum oxide, amount of silicon oxide, amount of iron oxide, and the degree of amorphousness of its structure means how much amorphous it is, how much base form it is. Also affects the pozzolanic activity and the thickness of its particles, fineness of its particles means the pozzolana particles are how fine. You can imagine that cement. Cement is of very nanoparticles. Those are cement particles. So a similar way, in pozzolana cement also the powder particles are nanoparticle size. So the fineness of its particles also tells the activity, pozzolanic activity. So pozzolanic activity, the binding nature depends on amount of silicon oxide. Simply silica is nothing but sand, aluminum oxide, and iron oxide. Means in normal construction, what you add? Iron, iron rods, and silica, cement, granules. So here also similarly, silica oxide is nothing but sand, aluminum oxide, and iron oxide. Same, those are content. So those in what form those are available, and after all mixing together, the degree of amorphousness of its structure and ఎంత పేస్ ఫామ్ లో ఉంటే అంత ఫాస్ట్ గా how amorphousness that much fast will bind obviously. Okay, if you observe any general house construction, you will understand all same manner how with normal cement house is constructing. Same manner, Pozzolana cement also using. So the first activity affects the pozzolanic activity, right? As I told. So this SiO2, aluminum oxide, and iron oxide content, how it vary? Let us see. The greater amount of this, greater its activity. So higher silica and higher aluminum oxide and higher iron oxide. So higher will be the activity. Okay. As per ASTM standard 618 and TS25, the minimum SiO2 Al2O3 for natural pozzolans is greater than 70%. SiO2 plus Al2O3 plus Fe2O3 have to mix in such a way that the mixture should be greater than 70%. Okay. So that is in the natural form. There is artificial form. What we are adding, fly ash we are adding. Okay. So whereas in if we use fly ash and class C from lignitide or subituminous coals. So in coals, this mixture SiO2, Al2O3 plus Fe2O3 greater than 50%. Class F pozzolana cement consists of greater than 70%. And silica fume consists SiO2 consists 85 to 98%. And blast furnace slag consists of means using pozzolana cement, we are preparing silica fume, blast furnace slag, and class C pozzolana cement and class F pozzolana cement, and these are all. So when you call it as silica fume, when pozzolana cement consists of 85 to 93% of SiO2. When you call that pozzolana cement as blast furnace slag, when SiO2 content is between 30 to 40% and Al2O3 percentage from 7 to 19% and calcium oxide is from 30 to 50%. So in these different ranges, we are calling those as silica fume, blast furnace, or class C pozzolana cement, or class F pozzolana cement. Hope you understand. Generally, in normal house construction, while you are constructing the wall, little dry you will mix sand, cement, and all. Sand, cement, water, and all. Little dry. But when you are applying plastering, little wetty, you will prepare the cement, sand, and water. In the same manner here also. Okay. For various purposes of construction, for various compositions will be varied. Okay. Hope you understand. And amorphousness means the paste form up to amorphousness depends on the amount of bonding you need. If you are applying for plastering, more for amorphousness. Okay. For chemical reactions, pozzolans must be amorphous. And for volcanic ash, volcanic tuff, and fly ash, silica fume are all amorphous by nature. Okay. Volcanic ash, volcanic tuff, fly ash, silica fume, these are all in amorphous form only. And clays contain high amount of silica and alumina, but have a crystallic structure. Okay, do not possess pozzolanic activity. These clays do not possess pozzolanic activity. And the third one, amorphousness and fineness. Pozzolanic activity increase as fineness increase. Is the fineness, the very fine powder, nanoparticle size. If you grind the pozzolana cement, then the pozzolanic activity will be okay. So here also in this pozzolana cement consists of volcanic ash, rice husk ash, fly ash also we can. Rice husk ash is nothing but when that voka, rice husk means voka. When we burn that, we get some ash. That ash also we can mix here. volcanic ash, rice husk ash, fly ash, condensed silica fume are obtained in finely divided form. So in this construction, even in the cement or where cement manufacturing plants, we can add all these ashes also. Those will give some other bindness in appropriate magnitude. Okay, so that is about different types of Pozzolana cements. Here you can have a look that fly ash appears like this, and silica fume appears like this, and granuled blast furnace slag appears like this. Okay, these three will mix and will form Pozzolana cement. Okay, so not necessary as per your syllabus point of view. Only thing you should know what is Pozzolana cement and how what the different classifications of Pozzolana cement and how the SiO2, Fe3, FeO2, and alumina oxide and all contents vary. Okay, these are all you have to remember. These uses of these pozzolanas. What are the uses? Direct use of pozzolana by mixing it with calcium hydroxide, extensively used in ancient times. So in ancient times, they are using directly this pozzolana by mixing with calcium hydroxide. Okay, but not very common now. So nowadays they are not mixing pozzolana with the calcium hydroxide. Okay, and use of pozzolana in producing blended cements, grinding clinker, and pozzolana plus gypsum. These three will give Portland pozzolana cement. You might heard Portland cement. So Portland cement is nothing but clinker plus pozzolana plus gypsum. This three combination is called Portland pozzolana cement. Okay, this is extensively used in producing blended cement grinding. Okay, blended cement and uses of pozzolana as an admixture. Uses of pozzolana as an admixture means cement plus pozzolana plus aggregate plus water. These four together give concrete. Okay, fine. These are the uses of pozzolana. Okay, so this is about today's presentation. Today we discussed lime and lime pozzolana cement. So these two are the most eco-friendly green building construction materials. Okay, this is about today's presentation. Thank you.